Hello everyone. In the previous videos, we have already discussed about this convolutional layer, and then we have discussed about this ReLU layer. And now let's move on to this particular pooling layer. And before this, if you guys remember, convolutional layer is used for extracting out features, and whereas ReLU layer is used to add non-linearity, which will help us in extracting out complex features. Okay, it is not necessarily be ReLU, it can be any other activation function as well. We just discussed it as ReLU, but it can be leaky ReLU, or it can be any other activation function that we wanted to use. So the main intention of using this layer is to add some non-linearity, and then followed by we'll be having pooling layer. So if you guys remember, when we are given an image of n cross n and we are passed through convolutional layer, while using convolutional layer, we'll be having something called as kernels or filters, which are responsible for extracting out the features. So for each kernel, we'll apply convolution operation. And finally, like on this input image, with the help of this first kernel, we'll be getting the first output that is of size n minus k plus 1 cross n minus k plus 1. Like that, how many such outputs we'll be getting? As we are having m kernels over here, we'll be getting m such outputs. Okay, this will be the output that we get from convolutional layer. After that, we'll be using some activation function, not necessarily be ReLU. If you're using ReLU, then we can call it as ReLU layer. And after applying this ReLU layer, will it change the dimensions? If you guys have seen the previous video, you will clearly understand that this will not affect the output. It just changes the values within these feature maps. Okay, so now the output shape will remain the same, that is n minus k plus 1 cross n minus k plus 1 cross m. Actually, the extra dimension will be m. As I am showing over here, I am not clearly writing it over here. Okay, so the actual output dimension is n minus k plus 1 cross n minus k plus 1 cross m. But if we carefully observe, the actual size is n, right? And it is reducing it by n minus k plus 1, and this k is not significant when compared to n. So let's say if we take some example, n can be something like 1024 cross 1024, whereas k can be very small, like 3 cross 3. So this can happen. If you carefully see, this is not reducing the size, right? So, and also if you are having more number of such features or kernels, filters or kernels, then it will even increase with the help of the third dimension, that is m. Like let's say we are having some 15 such kernels, then this will be 15. So the overall will be 1024 minus 3 plus 1 cross 1024 minus 3 plus 1 cross 15. So if we multiply all these things, it will be obviously greater than this one, right? This is just simply 1024 cross 1024, whereas this is 1022 cross 1022 cross 15. Let me calculate it. 1024 cross 1024, it will be coming up to 1048576, whereas this is multiplying up to, like, this is the difference. Even if we see this is actually lesser, we can directly send these pixel values to n and we can get the output. But after applying convolution operation, it is even increasing the number of values to be used as inputs, right? So that's why we'll not consider this directly. Instead, we'll try to reduce it further and try to extract out the feature information. That can be done with the help of pooling. So first we'll take the input image of n cross n. After that, we'll apply convolution, which will help us to extract out features. Let's take some example. The first filter is only wanted information about this ear. Okay, left ear, this one. Then only in this portion it will be showing significant information. In remaining all portions, it will not be showing any of the information, right? Remaining all portions, the almost the value of convolution operation will be either in negatives or near to -1, or it will be near to zeros, right? After applying this particular ReLU, here in this portion it will be showing the information regarding this particular left ear, but in all remaining portions it will not be showing anything. That means all this information is irrelevant and also it is redundant. So if we can remove all of this information and only extract out this information, it will be good, right? So that is the idea of pooling. In pooling, we'll try to reduce the size by only considering majorly this part. That how we'll be doing? We'll be doing with the help of several strategies. One strategy of pooling is, one such famous strategy of pooling is max pooling. Okay, so using max pooling, what we'll be doing? Let's take some input shape of 6x6. So let's say this feature map is having of size 6x6. Then on this 6x6, we'll be doing pooling, that is max pooling. And in pooling, we'll not be having anything like these kernels. We'll just mention something like window size. So let's say the window size is 2. So as the window size is 2, what we'll be doing? Let's say this is 6x6. As the window size is 2 and the feature map size is 6x6, what we'll be doing is we'll be checking the first window. So on checking the first window, whichever is the maximum value in this window, that will be keeping it in the output. Okay. So here for all of these four values, as the window size is 2, we'll be considering 2x2 portion. And in this 2x2 portion, whichever is the maximum value, that will be keeping it in the output. Okay, so that's why we call it as max pooling. We'll take out the maximum value and we'll be keeping it in the output. Let's say something, I'm writing some random values, minus 2.86, minus 3, 2, and minus 1.25. So in this maximum is 3. So we'll be placing 3 over here. I'm telling these values as just example. It is not the exact values in this feature map. Just for your understanding purpose, like this, among all of these four values, whichever is the maximum, that will be keeping it in output. And after that, in convolution, we'll move by one column, right? Whereas over here, we'll be moving by two columns. Okay. By default, we'll be moving these many number of columns. Okay. That is window size. It is based on window size. That we can call it as stride. So basically, stride is the number of columns or number of rows that we move after completing the operation. This we call it as stride. In the next video, we'll discuss in detail about this stride, and also there is another concept, padding. Okay, but for now, here as the window size is 2, stride is also 2. Okay, so which means that after applying this operation, we'll move by 2 columns and we'll place the output over here. So as we covered these two, then we'll again start from this point, because stride is 2. So we again move by 2 columns and we'll consider this. So the last output will be getting over here. And after that, as we reach this last point, we'll start from here. Okay, we'll move by 2 rows down and this part will be covered and we'll get that output. Like that, total, the output shape of this will be 3x3. Okay. So input shape is 6x6, whereas here we'll not be having anything like kernels or filters. We'll just have window size. So based on this window size, we'll consider that window in the input feature map, and from that window, whichever is the maximum, that will be putting it in the output. So if you're using something like average pooling, then we'll be placing the average value of all of these in the output. So how this will help is, if you see in all these portions, all the remaining portions where the feature is not present, the overall value of this will be lesser when compared to the values in this portion, right? So wherever the feature is present, there the values are significant values. So as we are applying max pooling, the significant values will come out and will be shown over here. Okay, so that is why we'll be using this max pooling, which will extract out the exact feature information and represent in smaller size. Okay, so here it is 6x6, whereas here it is 3x3. So almost it got half. That means if the input shape is 1024 cross 1024, it will get into 512 cross 512. So like that, there is a significant change in the overall size. This is about the three layers. First layer is the convolutional layer, which will extract out features, whereas second layer is the ReLU layer, which is used for applying nonlinearity, which will help us to obtain complex features out of the input image. And then finally, we'll be having pooling layer, which is responsible for reduction of feature map size simply. So this is about the pooling layer. In the next video, we'll go into the more details of what is stride, what is padding, and all these things. And also, after completing all of this, we'll see the overall picture of CNN as well. So if you have any other doubts, please comment down in the comment section, and see you in the next video. Bye bye.